C, you could not use the square root property because it had a second x term. So you had to just factor out the GCF and set those factors equal to 0. Then the projectile problem, I was just hoping you could pull all of this straight out of the problem. When does the projectile reach its maximum height? Well, I know the vertex is 164 because this is my H and this is my K. So projectile reaches its maximum height after 1 second. And what is the maximum height? It is 64 feet. And when does it touch the ground? You would just set that equal to 0. And use the square root property to solve that. And negative answers aren't applicable, so it would take 3 seconds. Any questions about those? Does anyone want to see any of those in more detail?
Good.
Oh, good. Okay. All right, then let's take a look at the mini review. Okay, so Michael, I changed my mind about 50 times on this thing. So you may have a different one because I had posted a different one earlier. So this is the one I finally decided on. So first of all, you need to be able to write the quadratic formula from memory. So that is what I'm hoping that you will be able to do. I'm gonna give y'all a second and then I'll write it out myself. Again, if you want to have a hard copy of this, it is listed under the homework. So here, x equals opposite b plus or minus the square root b squared minus 4ac all over 2a. Okay, so make sure that it's all over the 2a. Okay, then the discriminant, of course, is just this part. Just the b squared minus 4ac is what we would consider the discriminant. So if the discriminant is equal to 0, what does that tell you about the roots? So can someone tell me?
So you mean like in the quadratic formula, the root would have to equal 0 if there's a 0 under it?
If the discriminant is equal to 0.
Yeah.
What does that tell you about the roots?
You're just square rooting nothing. I mean, it's just like square root of 0.
Okay, so how many roots are there going to be?
How many roots? I mean, none. 0.
No. Okay, so let's say you have x equals to -5 plus or minus the square root of 0 over 2a. Say a is 1.
Yeah.
All right. So what does that mean here? We'd have -5 over 2, right?
Yeah.
How many roots is that?
Oh, okay, so there's 1.
1 root, right. And what kind of root is it? Is it real or imaginary?
It's imaginary because it's negative.
No, because if there's, you can have negative numbers are real numbers, right? The
Okay.
only time you have an
I was
imaginary
thinking
number,
natural numbers.
yeah, it's not, yeah. The only time you have an imaginary number is if there's a negative under the radical, because under the real numbers, that's not cool, but in the imaginary numbers is. So this would be one real root. What if the discriminant is greater than 0? What does that mean about the roots?
There are 2 real roots.
That's right. There's going to be 2, and what kind are they going to be? Are they going to be real, imaginary?
Real.
Real, right.
It's getting too real.
It's like, let's say you had x equals to, I don't know, opposite of b, let's say -5 plus or minus the square root of 25 over 2. So that would give me -5 plus or minus 5 over 2, which would be -5 over 2 plus 5 over 2, which would be 0, or -5 over 2 minus 5 over 2, which would be -10 over 2, -5. So that would be 2 real roots. All right, and then finally, if the discriminant is less than 0, what does that tell us about the roots?
It has 2 imaginary ones.
2 imaginary, right. Okay, because let's say you had x equals -5 plus or minus the square root of -25 over 2. Then that would be -5 plus or minus 5i over 2, which is just -5 over 2 plus 5i over 2 and -5 over 2 minus 5i over 2. So that would be 2 imaginary, no real. Okay, so then we have some application problem probably where you would have to use the quadratic formula to solve the problem. So this says, according to Facebook, from 2000 through 2020, the number of monthly active Facebook users in millions could be approximated by the quadratic formula, -10.024t squared plus 448.79t minus 2,990.5, where t represents years after 2000. When were the number of Facebook users 550 million? So what would we have to do first on a problem like this?
Set up the quadratic formula.
We're going to use the quadratic formula, but before we can use the quadratic formula, we have to have an equation. So what equation will we have?
Sorry, is this, we're starting to test 6 review, right?
Uh-huh.
Okay, because my number 1 here is slightly different. Oh, but you said that you were changing it and stuff, right?
Yeah, I changed it.
Okay, so let me get the newer one here.
Okay.
Sorry.
We would set that equation equal to 550.
Yes, right.
Yeah.
So they're saying that the number of Facebook users, which is our F in millions, is 550. So we're going to say -10.024 t squared plus. And then what?
Okay, we're supposed to be using the quadratic formula?
Yep.
Okay, so we've put it in order of descending orders. Okay, so now we're gonna have to find A, B, and C.
Right.
A is -10.02. B is 448.79. C is -2990.5.
Okay, watch it because.
Wait, oh, I didn't see the 550 there, sorry.
Yeah.
Okay, so we're gonna subtract that from both sides.
Right, right. You have to have it set equal to 0 and in order of exponent. Exactly. So.
But wait a minute. The 448.79 is missing the T.
Thank you.
Yeah. What that look like?
So that's going to be minus what?
Like 3,540.5.
Is that right? Yep. And now what do we do?
Yeah, so now we get the A, B, and C anyways.
You wouldn't factor this? I think I'd factor it. I'm just kidding.
But if we're doing the quadratic, then.
I'm just totally kidding. Yeah, I know.
Oh, wait, we're
No, I'm
choosing which
sorry.
one to
My
use.
sense of humor is not very funny sometimes. Okay, so
But wait a minute, we get to choose though, right? Which one is
you would, you
easiest?
could choose. Yes, you could
Okay,
choose.
I wasn't.
Absolutely, you can choose any way you want, but this thing won't factor.
Okay,
So,
okay.
yeah, you're right. Totally. Okay, so I'm gonna give y'all a minute to do that. Anybody get that yet? What X is?
Almost there.
Okay, good. This should actually be T, right? Not X. Not that it really matters, but. Anybody get it? Just T is all I want. Let me show you something.
No, I think I messed up somewhere.
Okay, let's see here. I can show you something. So if you're using a calculator, you can many calculators, you can just put it in all in one step. So I put it all in one step, and it came out to be 10.22. Just be careful with that. And what is that 10.22? What is that? What's the unit of measure there? What is T? So T would represent the number of years after the year 2000, right? So when would the Facebook users be 550 million? What year?
2010.
Yes.
$2011 though, right? Because it wouldn't carry you into 2011 if it's past 10?
Well, you're still in the 10th. Is that right? Let me think.
Because one whole year equals 1, and then
Yeah,
anything
I
past that
think
is into
you're
the next year.
20,
So that'll be
yeah, I think
2011.
you're right. Yep, that's kind of tricky. I don't mean to be tricky, but yeah, you're right. I think it would be 2011 because we're into the 11th year.
It'll be
So,
approximately like, what would that be
yeah.
like?
Now, I don't know about
March?
Matt, but I would take either one of those answers. All right, so now.
No, I think it's going to be 2010 and a fraction into 2010, right?
Well, if we're talking, okay, so we're talking about more than 10 years, right?
Yeah.
So we would actually be into the year 2011, right? Is that right? Am I thinking about that right?
Yeah, it's approximately,
No,
I would say like March 2011.
If we added 10, we would be at the year 2010, and then we go 0.22 into the year 2010.
So we would be in March of 2010. Yeah.
Yeah. 2010.
See, you confused me. I was
But sometimes in the context of the problem, you do have to like round.
Yeah. I was thinking, if I was thinking exactly like you were, Michael, I was thinking, well, that means we're into the 11th year, and we are into the 11th year, but we're still in year 2010. Right. Yeah. Because like I just turned, I'm not going to tell you how old, I just turned 39. So I am in my in my 40th year of life. Okay. So now we're classifying each function as even, odd, or neither. So what would this one be?
That would be neither.
It would be neither. No, wait, no, it's odd.
It is?
I'm just saying whatever you say.
Oh, so
Michael,
that,
I'm going,
yeah, because the
that's
X has a
right.
1 at the top. I forgot.
Yeah,
I was thinking the X with a 0 on it. I was thinking.
Yeah. So this would be odd. Yeah, because all of the exponents are.
Yeah, I get those two confused.
Right.
Yeah. One of the things I realized when I became an instructor was like the power of suggestion is just like really,
it's horrible. It's like
really bad. Like you can say anything, and if it just sounds good, I'm just like, yeah.
Oh yeah, that's great. And even when I'm checking people's work, a lot of times my brain will start doing the exact same wrong thing that they did. And I'm like, well, this looks good. Anyway, okay. So what about this one?
The second one, that one is neither.
It would be.
Sorry, neither. I guess my mic cut.
Yes, it would be neither because we've got both even and odd exponents, right? And then what about the last one?
Okay, that one is even. Because that one has
That
the
one
X
is even,
0
yes.
at the end.
So this one had a mix of even and odd exponents. This one has all, no. This one has all odd exponents. This one has a mix. And this one is all even exponents. Okay. So now if you're given a table of values, you should also be able to classify the data as even, odd, or neither. What about the first one?
Neither.
It would be neither. Why?
It doesn't pass through the origin,
Mhm.
and both sides are opposite of each other.
Right. Okay. What about the second one?
Odd.
It would be odd, right? Okay, so all those O's, opposite, origin, odd. And then this last one.
I'd say even.
It is even. For an even function, it doesn't have to pass through the origin. The both sides just have to be the same numbers. Okay, so you should be able to complete this table to make an even function. And also to make an odd function.
The first box should be 4.
Yep,
The 0x can be anything.
anything.
And the last box should be -5.
Yep. And what about the odd function?
First one should be -4.
Mm-hmm.
Second box should be 0.
Yep.
And last one should be +5.
Okay, I forgot to write something here. Okay, so I'm going to do this. Okay. This first one, even, odd, or neither.
Number one, I'd say is neither.
It is neither y.
It does not go through the origin. It's also
Right.
not the same on both sides of the y.
Right, it's not
axis.
symmetric to the origin, and it does not pass through the origin. So how could we make that odd if we wanted to make it odd?
Just bring it down about 3.
Right,
So you can put a -3 at the end.
right, you could just pull it down 3 units. And what about if we wanted to make it even?
You could change the cubed to a squared, I believe would fix that.
Yeah, so if we wanted to make this, even, I mean, if we wanted to make it odd, we'd have to do that. This is odd. And if we wanted to make it even, we'd have to do something like, instead of going up, we'd have to make that come down. Okay, what about number 2, even, odd, or neither?
Even?
It is even, right? And it can be even, you can slide that parabola up, down, all over the place, and it will be even. So this is even all the way. And the last one?
That one's neither again.
That is neither. Okay, how could we make it even?
Move it to the right about
Yeah.
4.5 unit.
Right, if we moved it to the right, this could be even. And how could we make it odd?
Put it on.
It would have to pass through the origin, right? And it'd also have to be going, one side would have to be going up instead of down. Good. Okay, so here, identify the minimum degree and the sign of the leading coefficient. All right, so I always do the leading coefficient first because it's easy. All you have to do to find the sign of the leading coefficient is to look at the very end, the tail end, and whichever way it's going, that's the leading coefficient. So what's the sign of the leading coefficient on this first one?
Positive.
Positive, good. And what about the second one?
Also positive.
Also positive, right. So if you look at the very end, if the very end is going up, the very tail end, then the lead will be positive. And if the very tail end is going down, then the leading coefficient will be negative, okay? Then the minimum degree, how do we find the minimum degree? What's that rule?
Turning points +1.
Yeah. Okay, so what's the degree of this first one? Minimum degree.
5.
5th degree, right? And the second one?
4.
I am going to make this. This one's going to stop there. Okay, so I'm going to go ahead and looking at these, just approximate where the local extrema are on this first one. What would be the local maximums or maxima? Approximately.
minus 0.5 on the
Yeah, I
far
like
left
that.
one.
Uh-huh.
3 and 3.
Mm-hmm. 3. Right. So those are our local maxima, right? It's always the y values. And then what about absolute maximum?
There is none.
None, right? Because this thing just keeps going higher and higher, so there's not any. All right, what about local minima?
I got -4.
Mm-hmm.
I guess it's twice over, but do we just
Yeah,
put
but
it
you,
once?
yeah, you can just say it one time.
Okay.
Yeah, it's -4 both twice, right? What about absolute minima?
Also none.
None. Right, because this thing keeps going down and down. Okay, on this one, that's a stopping point right there. What would be the local maxima? It's kind of hard to tell, isn't it? Let's do.
Like 3.5 off of that.
Yeah, that's good enough. 3.5. And then this one, let's pretend like it's an even number. Oh, that's a minima, sorry. So we only have one local maxima. What about, and why is this not a local maxima?
Because it's an endpoint.
It's an endpoint, right? And endpoints can't be local. All right, what about absolute maxima?
There is none.
None, right? Because this keeps on going up and up. What about local minima?
-4.
Uh-huh. And what else?
I mean, the absolute minimum, I think, has to be -4 also, right?
The absolute minima is -4, yeah. But is there another local minima?
0.
Yep. These are both bottom points, right, in the region that they're at. But the absolute bottom point is -4. And here's the fun one. Sketch a graph of a polynomial that has degree 5, a negative leading coefficient, 4 turning points, and 1 x-intercept. And y'all's graphs can look different.
Okay. We can just kind of like approximate this, right? But we need graph
Oh,
paper.
yeah, yeah.
Let's see here. Okay.
Anyone want to tell me what they drew?
Yeah, so I just started with I like to get the x-intercepts out of the way quickly.
Okay,
I think that I think you have to draw this as a upside down parabola shape. I think, because that's the only way
So-
that I could get 4 turning points.
okay, so tell me.
Oh, no, wait a minute. I put 5, so I'm wrong. Okay. Okay, let me start over again. So actually, no, this is linear. In its trajectory here. 1, 2, 3, 4. Yeah. All right. So anyways, yeah, you just have a line, and I put mine going to the first, what is it called? Quadrant.
Okay,
It goes through the first quadrant as a straight line into the, what is that, the 4th quadrant? And then I do all
Okay.
my wiggles after that.
like that?
Yeah, so mine would go through both the Y and the X axes. I mean, that's just how I thought about it in my head. I like to keep things as close to the origin as possible.
Okay, so something like this?
Yeah, as a kind of as a straight line, yeah. Okay, so then
Okay.
once you do that, then you do all your wiggles here. I just quickly did 1, 2, 3, 4 humps, and then
1,
just
2,
finished it.
3, 4.
Yeah, that's fine.
1, 2, 3, 4. Yeah. Good. That's fine. Anyone do it something different?
And mine came out kind of similar.
Kind of similar. I'm trying to think, can we do it to where it would all be? Yeah, we could do it to where it would all be under the axis too, right? We could do like that.
Yeah, if you keep one part of it as like a straight line, you can get your axes out of the way and not, or, I'm sorry, your intercepts out of the way without having to worry about where you're putting it.
Okay,
So
good.
that's a really good shortcut there.
All right, so here, sketch the graph and state if it's continuous. So the first thing I like to do on these is to think about what this is going to look like. So if we have y equals to 2x, what kind of line, what kind of a shape would that look like? Or what kind of a function does that look like?
A line?
A line. Going up or going down?
Going up.
Going up. And then if we had y equals to 7 minus x squared, that's the same thing as negative x squared plus 7. So what kind of shape is that?
Upside down parabola.
Upside down parabola, right? So we know basically that these are the shapes we're trying to get. So for the 2x, we're going to go between -3 and 0. And what kind of dots are going to be on the ends?
Closed dots.
Closed. And since it's linear, you really only have to do the end ones. You only have to really do the -3 and the 0, right? Because 2 points determine a line. But you can do all the middle ones too if you want. This would be 0. So that's the first piece. The second piece between 0 and 3.
Yeah.
And what kind of dots?
Well, the first one would be open dot.
Yep.
Second one would be closed.
So 7 minus 0 squared is 7. 7 minus 1 squared is 6. 7 minus 2 squared is 3. 7 minus 3 squared is negative 2.
Um,
0, 7, 1, 6.
I think I did one the wrong, I mean, so the 3 I got, so that's, because I guess I'm doing it backwards from what you're doing. So I got -3. Oh, wait, I wasn't squaring it. I was multiplying it by 2. Yeah, that's right. So that would be -9 plus 7. That is 2. Yeah. Whoops.
Yeah, it should come out the same either way when
For
you
some
write
reason,
it.
I was multiplying.
So everyone should have gotten something that looks like that. Can you see why there can't be, it's a typo if you put like an equal sign here? Why would that be a typo? Why could you not have equal signs in both places?
You talking about the top one?
I'm talking about this one, yeah. Why could we not have an equal sign here too? What would be wrong with that?
The function's not continuous, so it wouldn't make sense.
It wouldn't be a function at all, right? It wouldn't, because it wouldn't pass the vertical line test, right? We'd have a solid dot here and a solid dot here, and it would not, right? So if it was continuous, it really, well, even then it would matter because you still wouldn't know where to put that point. But yeah, so this one has to be, one of them has to be open. Okay, because what if I ask you what is f of 0? What would f of 0 be?
I got you. That would be the -4. Wait, hold on.
When x is
On
0,
this one, it
what
would be 0.
yeah, f of 0 just be 0, right? Because which one would we plug it in? Would we plug it into this one, or would we plug it into this one? We have to know that, right?
Right.
And so we know that we plug it into the first one because 0 is included in that inequality, whereas in the second one, 0 is not included. That's why we have the open dot on the 0. Okay, so is this function continuous?
No.
No. Okay, and that's all I have for today. If I was y'all, I would go through the actual review, the parts that we've done. We've done everything except for section 4.4.
Yeah, 4.4 is up, and it is ridiculously kind of short, if I'm being honest.
Yeah, it'll be
Pretty
short and sweet.
It's like if it does this, it's got more than one. If it does this, it's got more than one even. It's got more than one odd.
And then they want them to write the equations though that are
There is a
based on-
little bit. There's one little part that's like difficult, and it's like if your leading coefficient is in a positive or -1, you have to go back and figure that thing out a little bit. That is a little bit difficult, but you've done that with squares already, finding the leading coefficient.
So aren't they going to have to write the equation that goes with this?
Oh yeah.
Yeah.
But that's converting the 0 to the factor.
Yeah,
We
to the
talked
factor,
about
right,
that
right.
already. Now we're just officially talking about it.
Right. Also, I did put a Kahoot just for if y'all want to, just for fun. It's up under the homework assignments for practice. And it has a bunch of these kind of functions on it. If you want extra practice on that.